Now we are going to learn about set. Sets is a different language. So in this language, the vocabulary what we are going to use is n is set of natural numbers, w set of whole numbers, z indicates set of integers, and q for set of rational numbers, t set of irrational numbers, r is set of combination of both rational and irrational numbers. And one more thing is there, but we are not going to use now, but we'll study in complex numbers. Complex number is one set which contain real number and imaginary also. What are imaginary numbers? Imaginary and complex number contain I is root of -1. We will study this later. Now, from now onwards, we are going to use some symbols. That epsilon symbol, the first one, is actually belongs to or an element of. If A is an element of, I can say 4 is an element of natural number, 7/5 is an element of rational numbers, root 2 is an element of real numbers, something like that. And if we put a slash over epsilon, it means does not belongs to. You can easily say that Bangalore does not belongs to Tamil Nadu, -4 does not belongs to natural number, and more. And one thing like striked V, it's called for all or for every. For all motor vehicles, they must have RC book. For all natural numbers, 1 is a factor. Okay. And the other symbol, it look like a style T. This is called there exist. Some vehicles can be hired. You cannot ask someone to give his vehicle for some time, or so you may ask him to give me a ride for 100 rupees. Well, the collection of well-defined objects is called a set. Well-defined objects. You can't say everything is a set. Suppose if you ask someone like, who is the most favorite actor you like, they will have a different opinion. So this is not the well-defined object. But if you ask who have achieved this award, some award from government, or Golden Globe Awards, whatever, then some set of people will come. It will be a good collection of objects. So it's a set. And there are two ways of representing sets. One is raster form, other is set builder form. Raster form is directly writing all the elements like 2, 4, something like that. Set builder form is giving a description for that. A is a set of values of x such that x is equal to 2 power n, where n is a natural number, n is less than or equal to 10. Suppose the set has nothing, no element at all, this is called null set or void set. Or it may have a finite number of elements, then you can call the set as finite. Otherwise, if it doesn't end, it's an infinite set. Okay, when do you say two sets are equal? When they have same elements. If A has 1, 2, 3, 4, B must have 1, 2, 3, 4. Maybe in different order, but for another example, A is set of letters of the word loyal. B is set of letters of the word Loyola. Say both as same letters, so A equal to B. If at least one element not in the A which lie in the B, or not in B but there in A, then A is not equal to B. What is subset of a set? Suppose A and B are two sets. If A has some 1, 2, 3, 4, B is also having the same 1, 2, 3, 4, and B may have some extra elements, but whatever there in A is also there in B, then you can call A is a subset of B. Here are some examples. Set of people of Chennai is a subset of people in Tamil Nadu. But set of people who speak Tamil is not a subset of people in Tamil Nadu, because Tamil people are all over there in Bangalore, many places of the world, even in Saudi, England, Japan, many places. Before finding number of subsets of a given set, you should know what is cardinal number of a set. Cardinal number n of A means number of elements in A. Suppose number of elements in A is m, then if you are able to write all the possible subsets, the number of possible subsets including null set is 2 power m. So symbolically we can say if n of A is m, then n of p of A is 2 power m. And suppose a set has some 4 elements, then the number of subsets 2 power 4 is 16. And if you know how many number of elements, then you will be able to write all those things without missing anything. So that's why this formula is important. And in some cases they may ask us to find just the number of subsets. In that case, you just use the formula to find the number of subsets. You don't need to write all the subsets. Suppose if they ask you to write all the subsets, list all the subsets, then only you have to write that. Okay, all the possible subsets called power set. Suppose all the subsets of a set A contain a null set and the set A itself. Okay. The set A, B, C is an improper subset of A. All the other things are proper subsets. Non-empty proper subsets excluding that null set and set of A, B, C. All the other 6 things are called non-empty proper subsets. The proper subsets, all those things excluding that A, B, C, including that null set. Suppose a set has a null set in it. It is not a null set. A set contain a null set. Then possible subsets are null set, set of null set. Then subset of the subset will be null set, set of null set, set of null set, set of null set, set of null set. Suppose if you want to find out how many possible number of subsets of P of A, it will be like n of P of A, that will be 2 power 4, which is 16. How to use brackets in an appropriate way? If I write set of flower bracket of 4, 9, the set contain 2 elements, only 4 and 9. If I use closed bracket 4, 9, the set of all real numbers between 4 and 9, including 4 and 9. Symbolically we can say set of x such that x belongs to real number 4 less than or equal to x less than or equal to 9. And the other way, if we put open bracket on 9, then all those things are all real numbers are included, including 4 but not including 9. So wherever the open bracket, that curved bracket comes, that is not at all included. Now we'll see some operations on sets. Suppose A and B are 2 sets, then A union B is the combination of both A and B. Either A or something belongs to either A or belongs to B. You have to write all those things, but don't repeat the things. Suppose A is 1, 2, 3, 4, 5, 6 and B is 2, 3, 5, 7, 9. Then A union B will be 1, 2, 3, 4, 5, 6, 9 under the sets. Intersection. What's common between A and B? Something which belongs to A as well as B. Suppose A is 1, 2, 4, 7, 9, B is 1, 3, 5, 7, 9. Then 1, 7, 9 is the thing which common between both A and B. So A intersection B is set of 1, 7, 9. Now we shall see the difference between 2 sets. A minus B and B minus A is different. Suppose if it is A minus B, whatever there in A, you have to write all those things are in A. Wait a minute. Not all those things, but whatever there in B, that has to be removed from A. Simply whatever B likes, A doesn't like. So whatever doesn't B have, that whatever not in B, only in A, that only the answer. For example, A is 1, 3, 4, 6, 9 and B is 1, 2, 6, 7, 8. Then A minus B will be, carefully we can omit 1, 6. Yes, that 1 and 6 are the culprits which is there in B. So even if you omit those 1 and 6, you will have 3, 4 and 9. That is what A minus B. And when you are writing B minus A, it's now B's turn. Okay, omit that 1 and 6. So what remains? 2, 7, 8. So 2, 7, 8 under the set. That is what B minus A is. Complement of set is simply U minus A. You write all those things in universal set but not in A. Suppose universal set contain 1, 2, 3, 4, 5, 6, 7, 9 and 10. And A is 1, 3, 6, 9, 10. Then A complement will be, leaving those 1, 3, 6, 9, 10. The rest will be 2, 4, 5, 7 under the set. Now we are present some laws and properties of sets. Some schools they may use properties to prove it. For those students it is necessary. And some schools they say use Venn diagram to prove it. For those people it is not at all necessary. However, you just learned this. A intersection null set is null set itself. A union universal set is A. A union null set is A itself. A union universal set is universal set. Then universal set minus A, already we have learned that, that is A complement, that is A dash. A minus U, if you do that other way around, nothing, null set. A union A is A intersection A is obviously A. Then A union A dash. If you have something and something which you don't have, when you club all those things, you will get the universal set. And A intersection A dash, nothing in common, so null set. And distributive laws. A intersection of B union C is A intersection B union A intersection C. A union of B intersection C is A union B intersection A union C. And A minus of B intersection C is A minus B union A minus C. And A minus of B union C is A minus B intersection A minus C. Okay, and here De Morgan laws. A union B the whole dash equals A dash intersection B dash, and A intersection B the whole dash is A dash union B dash.